Let me share my screen. Okay, do you see it correctly?
Yes, I see it. I hope the rest of you as well.
I only have half an hour, so I have to withhold myself not talking here for hours about this interesting topic. First, I'll quickly go through some pictures about the history and example projects. Then I'll describe the main differences between the normal cost estimate and this printed cost estimate. And hopefully I have some time left for questions in the Q&A section.
Yeah. Eric, maybe quickly you have to repeat what your topic is in case people forgot.
It's about 3D concrete printing and the cost differences that occur over there. Briefly about myself and my company. I work at Witteveen & Bos. We are an engineering consultancy firm founded in the Netherlands, and still our head office is in the Netherlands. We have about 1,300 employees, 8 offices in the Netherlands and 13 abroad. We do not construct any projects ourselves. We're just engineers. However, a few years ago, we bought this printer, this robot, to learn from this innovation. And currently we have a robot in the Netherlands and in Dubai, where we print projects together with the contractor, and one in Singapore for further research. 50 years ago, long before I was born, the engineering firm looked something like this. And although I did learn to draw by hand, during my study, soon AutoCAD was there. And initially only a pencil and a drawing board was the tool of the engineer. And everything was two-dimensional, and the contractor made it into 3 dimensions. Currently, engineering is evolved a lot. All our designs are made 3-dimensional. And here you see a simulation of a fire in an underground station in the Brussels metro. And we make a digital twin, so we can investigate escape routes to the nearest fire exit. And also in infrastructure, everything is designed in 3D. And prior to any asphalt paving, we test the road digitally. This is actually a colleague testing the road for curves and emergency brake distances and so on. So many kilometers already have been driven before the construction starts, and learning points from that simulation are processed in the design. So in engineering, there were a lot of changes, but then looking at the construction, not much changed in the same period. If you look at pouring concrete, it's still done the same way in 50 years. And looking at the steel construction, it's done the same way. Okay, maybe a few more safety measures on the right side, but actually the construction did not have the same speed and evolution as the design did. But actually 3D printing is not new, because already in 1941, William Herschel invented this wall building machine. Again, not safe to put your hand in the machine, but he was able to pour concrete without formwork. And you can look it up later on YouTube. And a few years later, in 1944, he patented this machine, a wall building machine. But then it was silent for decades. Only up to 1995, Dr. Kosnevich found a contour carving machine, and he built actually that machine. But then again, it was silent for many, many years, only into this century, and now projects go up quite a lot. And a big evolution is ongoing for 3D construction in general. Okay, how about the research for concrete printing? You can print in plastics and in all sorts of stuff, but let's focus on concrete printing. In 2015, we joined the University of Eindhoven with the gantry printer. This printer has possibilities to move on the X, Y, and Z axis and actually lay a small slab of concrete, mortar, no stones in it. And when you put this picture in move, the left-hand side is actual speed and the right-hand side is fast forwarded. You see the printer is actually a 2D printer. It only prints layers. And this is the key problem to engineer, the speed and the length of the printing path. Because the difficulty is that you have to print fast enough to have a bonding of layers. So the concrete should be wet for the next layer to bond on. But on the other hand, you should print slow enough to get the concrete stiff enough. And the stiffness I can show you in the next movie. Look in the back of the left side. It collapses. So this is all the time the key difficulty in printing concrete. On the one hand, you want a stiff and dry mortar. Then it will be stable. But on the other hand, it should be wet enough for bonding. And especially that bonding is key for structural concrete. So bonding is tested as well. How does the material look like? Difficult word, I'm not going to try to pronounce this, but actually you can compare it with ketchup. From itself, it behaves in a solid state, and only when you put in energy, it becomes a fluid. Same example is toothpaste. It is stable in the tube. When you press it, it becomes fluid, but on your brush, it should stay there. So that is the difficulty in the research of the concrete mortar. Okay, some example projects. This building, you can say if it's a nice building or not, was designed for Dubai. And on the roof of this building, drones should land for inspecting the solar fields. And this building was printed on site. So not in a factory, but in situ. And the difficulty here was the climate. We're working in a desert. And what we all studied at the university can be thrown away because it is dry, it is hot. All environmental conditions are different. So unfortunately, we had to build a large tent around it to manage the climate a bit. But in the end, the building was finished. Closer to our head office in the Netherlands, we built another small building. And the NVBK was here a few years ago, and the walls were printed, but the roof was not able to be printed. So the roof was still traditionally made. And maybe you've seen it in the news. Last weekend, the first 3D printed house was opened in the Netherlands. And this milestone project is in Eindhoven as well. And this picture is right from the news. And you can even see the grass rolls are still fresh. You see the lines in the grass. So this is completely new and innovative. People are renting it already. Beside the buildings, we also tried to design a bridge. And you can argue about if it's a nice bridge or not, but we started simple because we have to convince the government that it is safe. And that was the difficulty. So we started simple, and it looks like pulling bookshelf, like pressing books to each other to hold it with post-tensioning cables. So the middle part is printed, and the end parts are precast concrete blocks with pre-tension cables. And in the end, it was opened, and it was the first 3D printed bridge. You hardly can see that it is printed, but it was the first step. Then we came to the next bridge, a bit bigger, and I'll come back to that later in the cost estimate. This bridge was more curved and architectural. And here you see the actual elements are hollow. This is also printed in a factory, not in situ. And the hollow areas are filled with pebbles to support the curved faces. And this element was printed in about 6 hours. So from a design into a prefab element, it is really fast. You skip a lot of steps, and the printer can work 24/7, so it doesn't matter. You come next morning and it's ready. And the last example project I'm going to show before we go to the cost estimate is this one. Actually, it's a series of bridges in a province, North Holland. And all bridges are alike, like a bridge of family, a family of bridges, and they're all kindly different shaped and currently being printed. How did we start? We started with furniture because we had to understand the material behavior better. And we wanted to print, but we faced a lot of building regulations and we weren't allowed to start just printing bridges. So therefore we started with these picnic tables, and especially the tight curves, the tight corners are tested, what was able to be printed. And these tables are besides our canteen near Witteveen and Bosch. And we did not write down all the knowledge into a book or a white paper. No, we have written a software tool with it. So now the software is able to not only design, but also calculate the structure. Let me check my clock. I think I'm on track. Let's go to the cost estimate. Maybe you know that typical cost questions are always asked at a Friday afternoon. And I don't know why, but this often seems the case. And it was a Friday afternoon. My colleague Hans called me, Eric, what are the costs of a bicycle bridge? So I imagine a small off-the-shelf wooden bridge from a supplier, maybe 75,000 euros. Call it the beam across the ditch. No, Hans said, it should be a concrete bridge. Okay, a simple concrete bridge, let's say 90 square meters times 1,250 euros plus indirect cost, maybe 150,000 euros. No, he said, based on architecture. So you noticed Hans was teasing me a bit. Yeah, bicycle bridge based on architecture. And asking further, the truth came out. This was the design of the Nijmegen Bridge. Wow, that one is not in our Witteveen and Bosch cost database. So how to make a cost estimate for this one? Do we have any good references? Actually, we don't. We only have this kind of ugly bridge in Gemert. But actually, it was good enough as a reference for the cost estimate. So you cannot make it as a benchmark or do reference class forecasting. No, you can still use it to have a bottom-up cost estimate. So the experience gained over there was used in Nijmegen. All our designs are based on this parametric model. And this parametric model is key for the design process. So not only visualizations are generated, but also the calculations are made. And of course you can put into unit rates into the model, but actually, personally, I don't like it to have a live link of costs in the model. So maybe that's old school, but the cost estimate is not completely automated. But the printer code is generated as well, the G code. And of course, a big benefit is that many bridges can be generated with the design being slightly different. So let's come to the cost estimate. If you want to refer it to an architectural bridge, we have to make a comparison as well. What does this printed bridge be more expensive than a traditional architectural bridge? So we looked for a reference. This is the Waalbrug in Nijmegen, also one of our projects. And this was a curved concrete structure as well. And here you see that the formwork is built twice. First in the workshop and later on site. Now let's say, what will the formwork cost? Maybe 100 euros per square meter for the support structure, and maybe 150 euros per square meter for the form system itself. So we have 250 euros per square meter for the form, and 0 for the printed bridge. So printing is still favorable. Next, we need reinforcement, of course. So in the curved bridge, all the reinforcement is bended and curved as well. So this was quite expensive. So how much reinforcement do we put in? Maybe 175 kilos per cubic meter, I assume. It's civil and not building industry. And now what will it cost? Maybe a bit more than €1 per kilo. So let's say 190 euros per cubic meter. 0 for our 3D printer, because we cannot print rebar yet. So 2-0 for the printer. Then we can start pouring concrete, right? So traditionally we have about 5 men working around with the vibrator and so on. Maybe including the mortar, 130 euros per cubic meter. And here our mortar is ready mixed concrete, so it's a dry mortar, and that makes it more expensive. And also a lot of research and development goes in. So the mortar is way more expensive yet. And officially I'm not allowed to call the actual figure, but it's about 7 times more expensive than traditional concrete per cubic meter. Another disadvantage of the printed bridge is that the volume is larger than with a precast concrete bridge or an in situ bridge. So we have a larger concrete volume. Of course, we have hollow areas as well, maybe up to 40%. So in total, the concrete is way more expensive. And now we can start printing our bridge, right? Sorry, we can't. We have to prove the design, and there are no regulations or norms to make a structural calculation for printed bridges. There's no Eurocode for that. So to prove our design, we need to follow this quality protocol. And in the first bridge, the straight bridge in Gemert, it looked like this. So we do not know the material properties. So we have to test the concrete. And then the next question was, is the structural behavior known? Again, we said no. So we have to make a real scale bridge and press it to test it on the bench and prove the structure. So that was quite a disadvantage for the cost estimate. Then the question was, is the quality of the actual structure known? And again, we had to say no. So we had to do trial loads in the field. Okay, this is not that expensive as pressing my bridge into aggregates, but this is costly as well. And then finally, the last question was, are the properties known over time? And again, it's not. We do not know the behavior of the structure over many, many years. So a lot of costs goes in monitoring. And to be honest, we don't know the lifespan of the bridge. Structures are designed for 100 years maybe, but this printed bridge, we don't know. Okay, so this was my example. Now go to the Nijmegen bridge, where we had to make the cost estimate for. We can skip the first part because we know the material properties. We've tested the cubes in Gemert. But because this design is totally different, we cannot say we know the structural behavior. So this is not a joke. We have to make a real scale element, 1/3 of the main span, to be tested according to the protocol on the bench. So this is one printed element being rubble again, being aggregates. So that is difficult for the cost estimate as well. So now summarizing it, let's say on the left-hand side we have a traditional bridge, and on the right side the printed bridge. So the abutments and the foundations may be comparable, assuming the weight is comparable. Then we had our formwork. As you've seen, we don't have any formwork in the printed bridge, so still in favor for the printer. The rebar, it's not there yet. So traditional is more expensive. Then comes the mortar. You see, it's getting closer. The mortar was more expensive, but it's still cheaper to print a bridge. Now, we have to do some finishing works, maybe some light and some road markings and so on. Now you would assume that the printed bridge is cheaper, right? But if you have noticed, the tests were not there yet. Also, we have to hoist the elements and make a support structure. The anti-gravity coating was more expensive, and we had some extra deck to avoid sun cracks due to surface tension. Yeah, and our mock-up test. And then again, all our investment and research and the universities. So we're not there yet, but we believe that by putting in effort in here, that in the future, the costs will be competitive, and all the research is done and we've learned from that. So final thoughts or conclusions. You can go directly from an idea to 3D, not making drawings, etc., directly printing. So maybe in the future, if you want an extension to your house, you're not calling an architect, you're just renting a printer. And with the printer, there comes the software to calculate and print your extension. So you have completely freedom in the design and so on. Yeah, and ongoing is still the material. The mortar is complex and printing rebar is difficult. Of course, we did fiberglass tests, but the difficulty with the fiberglass reinforced concrete is that all the fibers are laying in the same direction of the nozzle, and you want them to be scattered around. So that's a difficulty as well. And as I said, the lifespan is uncertain. That was my brief introduction to concrete printing. Hopefully there is some time left for questions. Yeah, looking to my clock.
Yes, your timing is perfect, Eric. We still have 7 minutes for questions.
Okay, please.
I have some questions. I know you don't know the long-term characteristics of the material, but what is your idea? Is it environmentally better to use 3D concrete than conventional?
Currently it is, because we only have one material type, so it's easier to reuse it. So the aggregates can be reused one-to-one. We don't have any rebar which you have to take out. We don't use any formwork which is thrown away. So in that perspective, it's environmentally currently better, but we do not know the lifespan, as I said. If this bridge takes lives for 50 years, then we have to build it twice. I don't know. So we did not make the CO2 calculations as Tim suggested with ICMS 3.
Very interesting. We have a question here. Somebody said very interesting. Sergio has a question. He says he has a question. Maybe Sergio, you can write it in the chat so I can read it aloud. Would that be possible? Otherwise, we can maybe take another question in the meantime. I was thinking, how do you see this develop also in terms of craftsmanship? You know, how will our world develop? Will we lose our craftsmen, or will we?
Currently not. There are more people involved in the printed bridge than in a traditional bridge, maybe, because everybody wants to learn and standing around, and you cannot just press Ctrl+P and walk away. So there's still a lot of manpower going in, but I think labor is changing. You don't have to do heavy labor and carrying wheelbarrows with concrete or hoisting concrete. So the work is changing. I don't believe our work will be gone. Same as the cost estimate. The cost estimate can be automated as well. Just put in the mortar price and the robot price, and it will calculate the number of hours, and the cost estimate is ready. But that was not the case. We can learn from automating engineering by being parametric. What is the effect of a larger span? What is the effect of a wider bridge? What is the effect of, so I think you can learn from it and the job will change and not go away completely. The tedious part, all calculating all the quantities, it's not necessary anymore. The quantities are there, so you can focus on the real actual job.
Thank you. Somebody's asking, are there different grades of printed concrete? Or different types?
To the concrete quality, there is not really. There's one mixture being optimized, and you cannot say it's C25 or C35 or and so on. It's just, this is the mixture, and the complexity is about being stiff enough to stand and being wet enough to stay there till the next layer comes. Otherwise it will collapse like the face did. So that is all the focus points, the stiffness of the mortar.
And somebody is asking, would it make sense to have regulations just for specific printed projects? Otherwise it will take ages to have this technology.
I think we're working on those regulations because we can skip a few steps already. First step was skipped, was the material tests. The second step we can skip was the test of the mock-up. So by doing this, it becomes more easy to do other jobs as well. We can prove the design and the calculations are in line with the actual behavior of the concrete.
Right, this is Sergio from Spain who asked this question. I can imagine why, because he is working for the EU on regulations of different products. He's also asking, is it possible to get the slide comparing both costs again, traditional versus printed? Could you share that again, maybe, Eric?
Put it on the screen, you mean?
Yes, please.
I can,
somebody's asking a question in French.
I made it.
And the workers, what are they going to live with then? Is it less work for these people? Right, so I think the worry is maybe some certain people with certain education will not or will be out of work if it's taken over by robots. What do you think about that?
Difficult discussion. As I said, I think more people are involved. The robot is not completely artificial intelligence building houses by itself. And you still have to feed the robot. I think the heavy work is carried out, and especially when you work inside a factory, the work environment of the workers becomes better. It's not working in severe climates, in rain and freezing weather. So the environment becomes better for the workers, and they're still there. The elements need to be hoisted and placed and so on. So I don't think by robotizing this, jobs are gone. But maybe we can have a comparison with the car manufacturing industry. Yeah, still people work in those industries, but not doing heavy jobs. Painting is done by a robot. Hoisting is done by robots.
So it's more supervision and controlling that everything is going right, and less physical, heavy load.
Yeah.
I don't know if in the rest of the world, in the countries, how it is, but a shortage on labor at this moment, and in the future maybe more is, of course, help with that. So there is less labor in the future, so people to do it. I mean, so we should maybe automate things.
Yeah. We have reached our time goal for just before the coffee break. Sergio would like your presentation, Eric, by email. I guess you have his address.
I do.
I'm sure.
Stay here for people asking questions during coffee break.
Yeah. And he's also saying great presentation, by the way.
Thank you.
Somebody asked the last question, is this concrete based on cement like normal concrete? Is it something else that might be preferable for CO2 impact? Can you say a last thing about that?
actual recipe is a top secret, I really don't know, but I assume it is based on cement, as it is from a cement industry, Weber and BMX. So I assume it is cement based, but they don't tell their secret.
Maybe it's old newspapers. That would be great, wouldn't it? No, jokes aside, thank you very much, Eric, for your presentation. It was really interesting getting a fresh input on what's going on around it all over the world in this area. Thank you very much. We will do a coffee break now and meet again at 4 o'clock European Central Time. That will be 3 o'clock in the UK, Ireland, and 5 o'clock in Finland, I think, if I'm right, or 6 maybe. I'm not quite sure, but we will meet up again in 20 minutes. Have a good coffee break, everyone. Thanks to the presenters who were already there, and see you in 20 minutes.
See you. Bye.
Dag Rutger. Wil je geluid testen? Soundcheck. Dag Rutger. Soundcheck.
Hi, Rutger. Nice to meet you. We haven't met before. Thank you for joining
hi,
us.
how are you?
Fine. How are
No.
you?
I'm fine. I'm actually done working for the rest of the day. So I have the rest of the day to give my presentation and join you in your webinar.
Oh, perfect. Hi, Rutger.
Perfect.
Hey, Crayon, how are you?
Thank you very much for joining us on such short notice. It's really appreciated.
Yeah, absolutely.
Oh, well, it's quite an honor.
Well, yeah, for us.
Yeah.
Yes, yes. And it really seems to be a very interesting project you're working on. So I'm very much looking forward to hearing about it.
Okay, well, I can hope, I hope I can meet those expectations.
I'm sure you can.
Oh.
We are just having the coffee break. So
Yeah.
we're actually doing very well on our time planning.
Yeah.
Our time schedule. So
How is it in Rotterdam, Rutger?
Yeah, it's fine. Rainy over here, but
It's dry.
it's okay.
it's raining in Switzerland as well. So you can all put some sunshine into our day during the webinar.
We are always with the colleague of Rutger. We are always joking in Rotterdam. It's near the coast, of course, so it's raining more there. And I'm in the south, so the sunny south. I'm 20 kilometers from the warmest point of the Netherlands, so here is always beautiful weather. So
Funny. I'm going to go and do this ICMS call.
Yeah.
Okay.
Thanks, Justin.
I'll be back for 3:30.
Yes, perfect. Thank you very much so far.
Yes.
Bye, Justin.
I have a building site up on the roof, so I will mute as much as I can when we're starting again.
Okay, good.
I hear it now. Good presentation, Eric. That was nice.
Yeah,
Thank you.
Very
Yeah.
interesting.
Timing is always a difficulty, but I didn't have to rush up the final slides.
Yeah. No, it was perfect. Also, the topic is very interesting.
yeah. And it was also nicely made. Your slides were really well made.
Thank you.
Crayon, I see we're only in the meeting with the panelists at this moment. Is it an idea that I try to share my screen to see if it all works?
Yeah, no, the rest is also there. There are 26 participants, but we cannot see them. But they are there. But just try. Yes.
Okay.
Yeah, it's something
So
happening.
you should be seeing a full screen now. Is that correct?
Yep.
Yes, we can see it.
Yeah.
Wow, that's beautiful.
Yeah, that's a very beautiful hall. That's amazing when you do it.
Yeah. So I guess, Roger, before we start again, maybe you take the presentation down just shortly.
Yeah, sure.
Before we start.